now what we have is I've measured the focal point on the near side of the lens to be right here, and I've extended the optical axis along right here, right? Now, because your lens isn't terribly large, we're going to make an object of approximately 1 centimeter in height, and that's what we have right here. And in fact, let me thicken this dot quite a bit, right? And here's what we have. So our object is here, and it doesn't really matter what we think of our object as. It doesn't really matter. It can be a candle, or it could be any order of things. But now what we want to do is place our laser at that point, all right? And we're going to send a laser beam down that is parallel to the axis, and that should get reflected through the focal point, and you can see that it does. Then we want a beam that goes through the center of the lens, and that should be unreflected, or I should say unrefracted. It does get reflected, but it doesn't get refracted. It doesn't get bent. It technically is refracted, but it's not bent. And then if we put one through the near focal point, the outgoing beam should be parallel to the optical axis. And where those beams intersect is the point where the image is, right? So let's see if we can do this. And I want to make sure that my laser beam is right on top of my object point. Right, and we need just a little bit more height. That should work. All right, so I want my incoming beam to be parallel as possible with my optical axis, and my outgoing beam. Now you are going to want to keep all of these beams straight. I'm not using different colors, but if you want to, it might not be a bad idea. And this one is going through the focal point, which is good. And next, we will put a beam directly through the center of the lens, and that should intersect the optical axis right at the point of the front of the lens. Actually, what you really do want to do is look inside the lens through here and make sure that it's going through the middle of the lens. All right, that's what you really want to do. And trace that beam. Right. And then put one through the optical axis, or I'm sorry, through the focal point. Right. And this is the one that if you skip one, you can skip this one. All right. If you skip one, you can skip this one. And in fact, I think I'm going to, only because I think I've accidentally shifted things around more. Again, you might want to tape your things around, tape your apparatus down. But it'll be good enough for government work. it would be advantageous to use a straight edge here. But in any case, all right, where your beams intersect, all right, and in our case it is right about here, all right, right about there. And so your image is going to be right here, okay? Your image is going to be right there. Now, what we want to do, okay, the whole point is to take a ruler and measure this distance for your object distance. So you want to measure from here to here. Label that as your object, right? And then from here to here, label that as your image. And from the equation, the thin lens equation, 1 over the focal length is equal to 1 over the object distance plus 1 over the image distance. You can then calculate where the image ought to be and compare that with your measurement from here with your ruler. And then you can also compare what ought to be predicted for the image height okay, so that is what the object of this lab is. All right, we'll see you later.